Okay, so let's quickly review what we talked about with an ellipse today. So let's try to remember that this is very well connected to a circle. There are a couple of things that are different. One of them is that it must be equal to 1, okay? And each is going to be divided by a squared and b squared, okay? So we talked about how a horizontal ellipse is going to have a underneath the x because a is always the greater number. So here, if a is under the x, it's going to be a horizontal ellipse because the distance from the center to the vertex on the x is going to be biggest. And then if the a is underneath the y, then we know that that's going to be the longest distance, so it's going to be a vertical ellipse. So what does this look like? Well, if I was to take this equation, right? I have the center is 3, 2. So that's going to be our center, and I'm just going to sketch it here. The biggest number is under the y, so that means it's going to be a vertical ellipse. So a is going to be 5 because a squared is 25. That says a squared. Okay. And then the b is going to be 4 because the b is under the x. That means it's going to be the shorter distance away. So how do I sketch this? Well, I find the center, 3, -2. I put it in here. And then I say, well, my b is under my x, so that's a distance of 4 away. So there's going to be my vertices there. And then I have my 5. I go a distance of 5 away, and I just do my sketch. Okay, so let's do one quick problem. What if I said x plus 7 squared over 36 plus y minus 2 squared over, I don't know, let's pick 144 equals 1. So pause, write down the center and the vertical and the horizontal distances from the center and see if you can sketch it and then come back to this. So we know that a is equal to 12 and b is equal to 6 because a is going to be that bigger number, that's a squared of course, right? And b is under the x, and that's b squared of course, all right? My center is going to be -7, +2. If I sketch that, I have -7 here, +2, let's say. All right. I know that this is going to be a vertical ellipse. That means it's going to be elongated vertically. So I would go up here 12, and again, this is just a sketch. And I'd go down here 12, and then I'd go over here 6, and I'd go to the left 6, and I have my sketch. And I just do my best to sketch that guy. Now the cool thing is for the homework in the packet that you have, you're going to have, of course, you're going to have coordinate planes. And I kind of can see that my sketch is a little off, so I'm going to modify this, and there's my sketch. So one quick question. What happens when the a and the b are the same number? What do you think is going to happen? So this is my question to you. What happens when the a and the b are the same number? So think about it. If the a and the b are the same number, what does that mean my graph is going to look like? Okay, so pause it, think about it, and I'm going to give you the answer right now. Well, if my a and b are the same number, that means that my horizontal distance from the center is going to be 9, and my vertical distance from the center is going to be 9, which means that we don't have an ellipse anymore. We actually have a circle. But this is in ellipse form, isn't it? I can look at this, and I know that this is a little hard to see. Okay, so I'll just say it again. Here's the center, 9 to the right and to the left, 9 up and down, and of course these are radii, and this is going to be a circle. So the answer to this question, so what happens when A and B are the same number? It's actually a circle, okay? So what I can do is imagine I can multiply the entire equation by 81. And when I do that, look at what happens. I get x minus 5 squared because these 81s reduce to 1. These 81s reduce to 1. And now this is going to be equals 81. So now you have a circle equation, okay? And if you have a circle equation, what's your center? Well, again, pause, think about the center and the radius, and then see if you're right. So the center is going to be 5, comma, negative 2, and the radius is going to be 9. So if I wanted to graph that, I could graph that, but it's a circle. So that's what happens when the A and the B are the same. One last quick thing. I want to talk to you about recognizing a graph and then saying, well, what is the equation of this graph? So how do you do that with a circle? You do it almost the same way with an ellipse, except remember that first of all, my ellipse has to equal 1. So I'm going to write that up there, right? And I know that my ellipse is going to be 2 fractions, okay? And I know that my A is going to be my biggest one. So what's my A? My A is going to be 1, 2, 3, 4, 5. So if my A is 5, I'm going to put that under my X value. And don't forget I have to square it. And then my Y is 2, 1, 2. So I'm going to put that under my Y value, okay? And that's a horizontal ellipse. So the question, what remains is, well, what's the center? Well, the center here says 7, negative 1. 7, negative 1. How do you put that into your equation? See what I'm doing? I'm opening up the parentheses. So 7 is going to be x minus 7, and negative 1 is going to be y plus 1. And this is the equation to this ellipse. And of course, I can always check that by just picking any point on the ellipse. Of course, I would pick those integral points, put them back into the equation, and they should check. So this here is 7, comma, 1, 2, 3, negative 3, right? So if I take this number and put the x value into here, 7 minus 7 equals 0. Oops, squared, excuse me. Plus, put my y into this guy, negative 3 plus 1 squared over 2 squared equals 1. So this should come out to be 1 if we're right. So 7 minus 7 is 0 over 25 is 0, plus negative 2 over 4, right, equals 1. And is that a true statement? Yes. I just don't want you to see that. Okay. So that is 0 plus negative 2 squared is positive 4 over 4, and that equals 1. So I kind of know that I did that. I could check it with all of these points, but I'm not going to. Okay? So last but not least, how can I take the equation of an ellipse and actually graph it? We're going to graph it here. I chose this one on purpose. Okay? So first thing we want to do is identify our center. And our center is going to be negative 3, comma, negative 5. Okay? I can recognize that the 36 is under the y, so this is going to be a vertical elongated ellipse. Right? So I'm just going to kind of sketch that there. And I know that my A equals 6 and my B equals 3. So I'm going to go through and graph this. Now I really want you to check this out. Okay, I'm going to take about 30 seconds to do this. So I go 1, 2, 3, 1, 2, 3, 4, 5. There's the center, negative 3, 5. The next thing I'm going to do is I'm going to count my A, and my A is underneath my Y. So I'm going to count 6 up, 1, 2, 3, 4, 5, 6, and put a point. 1, 2, 3, 4, 5, 6, and put a point. And then I'm going to take my my B, which is the smaller number, and that's going to be our horizontal distance, 1, 2, 3. Oh, that fell right there. And 1, 2, 3. Okay, so I have these 4 points. Do I just do one big swoop? No. Pick up your pencil and sketch it nicely. And so it might take you a little bit to do this, so it's a good sketch. Okay, it might take you a little bit to do this. I'm going to twist my paper around so I try to do this as best as I can. Okay, I'm not a pro in doing this either, so you're just going to do the best you can. Remember, taking a little bit of extra time won't kill you. Okay, you see what I'm doing? I'm moving it all around. Pretty good, okay? It's not perfect, but it's pretty good. So I'm going to take that, and then I'm going to, now you don't have to do this, but I'm going to do this. I'm going to go over it with a marker. Nice and slow. Wow, I think that's pretty impressive. If you hold your breath, you're less likely to go off the lines. And there it is. That is the equation. And that is the ellipse. Okay? So I want you to practice that tonight by going to your packet and doing those couple of pages. Okay? All right. Less than 12 minutes. Woohoo!